Well, welcome to today's tutorial, and we're going to be looking at controlling multiple servos using millis. Now, with this code, you will be able to control multiple servos going at different speeds in different directions. So let's have a look at what's on the breadboard. So this is the project running on the breadboard, and at the moment I've got 7 servos. I've only got 7 servos because I ran out of space and servos. So what do we have here? So we've got the Arduino Uno. You could have picked a Mega, Nano, ESP32. The board is irrelevant. I've then got a breadboard power supply. One of the things you have to be aware of is that an Arduino, although it's got a 5-volt pin down here, that 5-volt pin is nowhere near powerful enough to start powering this many servos. An Uno is only strong enough, if you like, it's only got enough oomph to move a single servo at best. Now here, sorry about the angle of this. This is the PCA9685 board. So this is connected to the Arduino using analog 4 and 5. So let's take you over to the Digital Town website and we'll quickly show you the wiring diagram. Now, as usual, there is a dedicated page to the project. It'll give not only the wiring connections, but also the code is available as well. So this is a PCA9685 board. Obviously, you connect your servos onto these row of pins. You can change the I2C address of the board by soldering across these pads. For this project, I'm just using the default address. And then we've got our connections. Now, there is a VCC here, which is to power the board. There's then a power pin here, which is actually for the servos, and I think it's linked to this one here. I'll be honest, on the setup I've got, these 2 pins are currently connected together and just go to the breadboard power supply. Then you've got your SDA and your SCL pins, and obviously your ground. Now, connections to the boards, if you're using an Arduino Uno, your SDA goes to pin A4, your SCL to A5. Going down a little bit further, you've got some connections for the Mega, and I've also done an ESP32. And if you go to the Arduino reference, just click on that one, and you've got all of the I2C connections for all of the other Arduino boards. So going back to the project, what I want you to notice about these servos is not only are they all moving in different directions, but they're also moving at different speeds and to different angles. So each servo is constantly being fed a series of instructions, which I'll show you in a moment, but each one is able to work independently of each other because there is no blocking code within the sketch. So let's start to take a look at the sketch we're going to be using. So going up to the top, obviously I'm using an Uno, so I am connected to A4 and A5. We've then got the Adafruit PWM servo driver, and I'm setting up my object and I'm calling it servo board. Coming down, we've got a few items that we need to define. These are some limits for the servo to move between. I would tend to leave those alone as the default values are pretty good. And then going down to the setup, we start my servo board and I then set the frequency of the servo board. So that's the basic Adafruit bits. Now let's look at the code that I've wrapped around it. Now, the main things within this sketch are this variable here, an unsigned long for current millis. Going down to the main loop, I place this right at the beginning of the main loop, and that keeps track of the current time of the board in milliseconds so that I can use that globally throughout my sketches. So going back up then, I've got an unsigned long for a variable called reset millis. This is just a timer that I am using as a way of giving new instructions to the servos. So if you like, it's not really required for the servo control if I was just using the functions I've created, but it just helps to feed random values, as you'll see in a bit. Alongside that is the reset timer, because it's doing it every 2 seconds. The next important variable, if you like, for the sketch is an unsigned long array called servo millis. Now notice it's a 16 element array because the PCA9685 board has 16 ports. So it's going to save a value for each port, because this sketch can be scaled from just using one servo right through to the full 16. I've then got another unsigned integer. The reason it's unsigned is I didn't want anybody accidentally putting negative values in. Servos like to move between positive values. So again, it's got 16 elements to match the 16 elements of the ports, and it then has 3 items per element. So if you like, we've got a target angle, the current angle, and the speed. Now with the Adafruit library, you tend to use these weird values, sort of I think they call them microseconds or something, to set the angle that you want your servo to move to. I always find that a little bit confusing. So in my sketches, I prefer to actually enter a physical angle. So in this, there is the target angle. The current angle is the angle that the servo is currently at, and the speed is the speed in milliseconds, which is basically, if you were using the old delay system, that would be the delay between steps. In this sketch, we don't use delay, but that speed setting works in exactly the same way. Now, to make life a little bit easier for myself, I've defined some items here. So if you use these items, let's just type something in here. So servo data 0. If I put this in here, if I enter a line like that, that is going to set the servo on port 0 a target angle of 22. Now, as soon as I sort of set that line off, the servo will start to move towards that particular position. Again, if I wanted to set the speed, let's say we're going to have 15 milliseconds between each step. All it requires is a line like this. So I've put that in there just so that it makes the code a little bit easier to use, but you could use the values 0, 1, or 2 instead if you wish. So let's just delete that out for now. So that's our data array. And then when we go down to the main loop, in many ways on the sketch, you can sort of forget this bottom section. The only thing that really matters for the servo control is this single function. So let's take a look at it. So this is our function, and it's quite a small function. The way that this works, obviously, we've got 16 items in our array because we've got 16 ports on the PCA9685 board. So it starts off by working through all 16 ports. Now, the first thing it does is it goes for this if statement, and it's checking, has the board reached its target that we have set. So servo target is where I want the servo to move to, if you like. That's the angle that I want it to go to. Servo current is the position that the servo is currently in. If those two values are not equal, then that means that the servo still has some distance to go. So once we know that that servo's got to move, the next thing we've got to ask ourselves is it time to move? And that is done using this line. Now this is a pretty standard way of using a timer using millis. So we've got that value, current millis, which is the time that was taken at the beginning of the loop. Then we're going to subtract the servo millis, which is the servo millis, not just any servo millis, but the servo millis for this particular port. So if we're going through, this is going to be a 0, this is going to be a 0, this is going to be a 0, and obviously as we go through this for loop, it's going to keep incrementing. So if the difference between these values is greater or equal to the servo speed value that we put into the array servo data, then we know that it is time to move the servo another step. Now what happens then is we reset servo millis to current millis. That way this if statement is ready to run next time. The next check that I do might seem an odd check, but this has to be done because this could be the first time that the new value has been entered, and all it is doing is checking that the target value is not greater than 179, because a servo moves between 0 and 179. So if you put a higher figure in, the servo is going to have a bad day. So if the number is higher than 179, it replaces the value with 179 so we don't break our servo. Once we have a valid value for our servo target, then we start to move into this section. And all this is doing in this area is it's an if statement that's trying to work out which direction does the servo need to move in next. So it's saying that if the current position of the servo is smaller than the target value, so let's imagine the servo at the moment is at 5 degrees and our target is at 10 degrees, then it says, okay, so we need to increase the value by 1 to start to move towards our target. Therefore we increase the value, and obviously if it was the other way round and the current position is at 100 and our servo is at 10, then it needs to start to go negative. So we subtract 1 from the value in this line. Once we've updated the angle that we now want the servo to move to, because don't forget it's only going to be moving 1 degree at a time, we then need to send that to the servo. Now the Adafruit library does not use degrees, it uses a value between US min and US max, and if we go up here, those values are 600 to 2400. Now these are, if you like, these speeds in microseconds. It's a value of microseconds that is sent across, and as you can see it starts at 600. That's because the servos act quite weird below 600, and it stops at 2400 because they can get funny above that value. These values here tend to be altered according to the type of servo, but the default values seem to work fine with the sort of MG90, SG90 type servo that I'm using. So going back to our code, we're going to use the map function that takes our 0 to 179 degrees and then maps that on top of the minimum and maximum value that the Adafruit library is using. We then put in our value, and that works out, if it's 10 degrees, what is that between these two values, and that stores it in this variable send position. Now if you don't understand the map function, there is a link at the end of this video to a tutorial I've done on using that function. So finally we then send this variable to the servo queue, because don't forget we're looping round. So this is the first servo and we send that value off. This is looping extremely quickly, so it's going to work through all of the servos. It's going to be checking if it's time for all of them to take their next step, and if it is time, they will move, just as we see in the video. Now, going back to the webcam, you can see obviously they're all moving at different speeds to different positions. I needed a way to program that, so I'm now going to show you how to send the instructions. So coming back to the sketch, in the bottom of the loop, I've actually put a note in here just to help you on this. So changing the value of the servo target part of the array at any time will instantly cause the servo to start moving towards that new position. So even if the servo hasn't got to its last destination, changing the target value will immediately change its direction towards that target. At the same time, we have a servo speed part of the variable, and changing the servo speed at any time will instantly start to impact the speed that the servo is moving. So you could actually write it so that the servo speed is incrementing so that you get a form of acceleration. Now, the other bit that you need to do is to find out, well, has this servo actually got there? Or how close is it to getting there? And that's always done by checking the difference between the servo target and the servo current. So with that in mind, let's look at how I have sent these random values. Now obviously I've done this because I didn't want to start adding buttons, but what I am going to show you how you set these things, you would do this exactly the same way if you wanted to use maybe a button. So I've got a timer here that's using millis, and basically it's going through all of the servos every 2 seconds just to see if they've reached their destination. And it's doing that obviously with here, is this servo target equal to the servo's current position? If it is, it's reached its final destination. And then all I'm doing is changing these variables. So I'm setting the servo target part of the array to a random value between 0 and 179, because the servo moves between 0 and 179 degrees. And then I'm also setting the servo speed as a random between 0 and 170. Now, if you were using a button, you might put sort of, let's just not write proper code, but if button pressed is greater than 0, let's imagine we've just read a button, then we would take these 2 lines, paste them in, and you might, instead of putting random, you're going to put the angle at 90, and you're going to set the speed at 15. And obviously you're going to do that for probably a specific servo. So let's say you're going to do that for the servo plugged into port 0. You may want to do that for a number of servos, in which case when your button was pressed, let's do this for servo 1 and servo 5. So at this point, all of those servos are immediately going to set off at exactly the same speed to the same destination. So although I'm using, if you like, a random system, you could set this off with a button, use whatever you want to trigger the output. Right, let's just get rid of that and go down to the next lines. So all I've then done is I'm printing to the serial monitor which servo has been impacted, the target that it is now being set, and its speed. And if I show you the serial monitor, you can see that it's coming up in batches. The number of servos that are impacted on each batch varies. You can see I've got a shorter batch here, then I've got a longer batch. It's all to do with the number of servos that reach their destination within that 2-second period. But you can see if I just stop the movement, you can see here that it's saying servo 3 has reached its target, so it's now going to set it a new target of 59 at a speed of 27. I've got servo 9 is going to go to an angle of 177 at a speed of 18. That's a little bit sort of quicker. 11 is going to go to 134 degrees, speed of 47, and so it is working through. And obviously if a servo takes a long time to get there, it won't be ready when my next 2-second read is done. So that is basically how the sketch works. This is a very, very simple way of controlling servos, sending data to servos, being able to move multiple servos at the same time. But the important thing is that within this function, there is no delay. So that means that nothing else in your code is going to be blocked, and you can run multiple servos, as you've seen, in multiple directions at exactly the same time. Now, going back to the webcam, obviously I've got 7 servos on here at the moment, but within the code it's actually sending values through for all 12 servo ports. But one of the things you need to be aware of is that if you only needed 1 servo, you can still use this code and just send the updates to that one particular servo and just ignore the rest, and the code will look after everything for you. So I hope that's been useful to you. A lot of people seem to want more and more information on using these PCA9685 servo driver boards. So if that's been useful to you, please click the like and subscribe. And just remember, there is a link at the bottom to the code on the Digital Town website. So see you in the next video. Bye for now.